have our acceleration. So acceleration will definitely be the 2s dt square. That means we have to differentiate this once again. Where is our ds dt? This is our ds dt. So we have to differentiate this once again. So if we have to differentiate this one will give us 2 times 2, 4. Subtract 1 from this, then we'll have 4t minus, what you have here is 1. What you have here is 1. 1 times 17 minus 17. 1 minus 1 is 0. 0 raised to power t, 1. 1 times 17, that gives us minus 17 here. So this one, which is a constant, when you differentiate the constant, you have 0. So that's what we are going to have, and this is our acceleration. This is our acceleration. So at this point, we have to determine, and the question asks us to determine our acceleration when it is momentarily at rest. So automatically, we are since our time, the respective time, we have 7 seconds and 3/2 seconds. So let's test for when t is equal to 3/2. Then we have a to be equals to 4 into t, which is 3/2 minus 17, and that will definitely be 2 here 1, 2 here 2. 2 times 3, that's 6 minus 17, and that will give us minus 1 that per second squared. This one is telling you that it is what? Deceleration or retardation, because when you have your acceleration negative, then it is talking about deceleration or retardation. But the question asks us to find the acceleration. So let's try the second one. When t is equal to 7 seconds. This one is when t equals to the. Then here we have a equals to 4 into 7 minus 17, and that will give us 4 times 7, that's 28. 28 minus 17, that will give us 11. So 11 meters per second. So definitely we have our deceleration, which is retardation, and we have our acceleration. So the answer to the questions will definitely be in two-fold. We have in two folds. We have this, that's the retardation, and we have this, which is the acceleration. So there are 2 values that we're going to get for the answer to this question in example 1. Rates of change. That is the next subtopic. Rates of change. For the rate of change, we usually resolve into what is known as chain rule. And chain rule is under what? Function and function. You can have 2 conditions. When you have it increasing, when you have it increasing, and when you have it increasing, it means y increases at, or as y increases as x increases, as x increases, and at that point of increase, we have dy dx is greater than 0. That's increasing. The point of this. Then we have the second case where you have it decreasing. Where you have the rate of change increasing, rate of change decreasing. So at the point where the rate of change is decreasing, we have y decreases. Y decreases as x increases. As x increases. Then we have dy dx is less than 0. So these are the 2 conditions. Rate of change can either increase or decrease. When it is decreasing, when it is increasing, dy dx is greater than 0. And when it is decreasing, dy dx is less than 0. Let's see the application in real life situation. Look at this example. The radius of a circle is increasing at the rate of this. 0.01 centimeter per second. Find the rate at which the area is increasing when the radius of the circle is 5 centimeters. So if you are to attend to this problem, the solution here, we assume that let the area of the circle be A with radius R. The area of a circle is definitely, the formula is pi r squared, as A is equal to pi r squared. The question asks to find the rate at which area is increasing when the radius of the circle is this. So automatically that is dA dt. The question asks to find dA dt. So now, by chain rule, we know that dA dt can be dA dr times dr dt. Dr dt is given to us in the question, and that is the radius of the circle is increasing at this, so that's 0.01 centimeter per second. So automatically, dA, since our A, the area of a circle is pi r squared, so dA dr will definitely be 2 pi r. This is a constant, we differentiate this, and when you differentiate this, you have 2r. 2r times pi, they have 2 pi r. Then that means our dA dt, which is equal to dA dr. dA dr is 2 pi r times dr dt, and that's 0.01 centimeter per second. So automatically, we have dA dt, and remember that the radius is given to us in the question to be what? 5 centimeters. So we have 2 pi times 5 times 0.01 centimeter per second. And if you multiply this by this, we are going to have dA dt to be 2 times this, 10 times this, that will give us 0.1 pi centimeter square per second. So this is our dA dt with respect to pi. So pi is part of our answer. But in case whereby pi is given, which if pi is given as 3.142, then you multiply it. So if pi is given at 3.442, so 0.1 times pi will now give us 0.3142 centimeter square per second. And the answer to this, the rate at which the area is increasing, will definitely be 0.3142 centimeter square per second. Integration of simple algebraic function. Integration is simply the twin brother of differentiation. So in differentiation, if you have y equals to x and we want to differentiate our y with respect to x, we say dy dx. Now, if this dy dx, if the dy dx is now equals to x, for example, then we will say that over 1, then we can say that we cross multiply this, then we have dy x dx. Then if you integrate this, we integrate this. So if we integrate this and we integrate this, or we can say if you integrate it and we integrate this, or even from here, so we have, if you integrate this, then it will be y. And if you integrate this, then you write this one, integral of this dx plus probably c. Or we can say that y equals to x squared over 2 plus c, where c is equal to the constant. Now the formula of integration. We have if y equals to ax raised to power n